Math 20-1 students. I wanted to introduce you to your quadratics unit. So that's going to be quadratic functions and quadratic equations. So what's important is that you want to look at the homework sheet, and for each lesson that you do, you want to practice so that you are really confident in this unit going into Math 30-1. So this unit, a lot of the concepts will repeat themselves and are very important for Math 30-1. So what we're going to do is we're going to look at vertex form and summarize what I wanted you guys to take out of that Desmos assignment. So I want you to know that you should always label your vertex. That's either your highest point on the grid or your graph, or the lowest point on the graph. Another thing that's important is this axis of symmetry. So this line that cuts it straight down the middle, in this case, these are called your axis of symmetry. Then we want to label our x-intercepts. So that's any time that the graph touches the x-axis, those are called x-intercepts. And in this case, this one is also a y-intercept because that's where the graph touches the y-axis. Also, our vertex, the y-coordinate will tell us if it's a max or a min. If that's the highest point on your graph, this one is called a maximum graph. And this one, since it's the lowest part of the graph, the vertex, it's called a minimum graph. Now this one is downward facing, and this blue one is upward facing. Now, from your Desmos, there were all these different features that I wanted you guys to look at and figure out what they do. So this is called vertex form. Now, the A, what you should have found is that if it's positive, you should find that the parabola looks like a smile. It's upward facing. Now, if your parabola is negative, it's going to look downward facing. And then we have our p-value. Our p-value either moves the graph left or right. Okay. Now, what you got to watch for is the P is kind of like the opposite of what you think is happening. So if you see a negative in front of P, that actually means you're moving it to the right. So that's when you see a negative. In the equation, if you see a positive in the equation, that means it's moving to the left. And Q, it can move it upwards or downwards. So if you see that there's a plus sign in front of Q, it's going to be moving up. If you see a negative sign in front of down, it's going to be downward. It's going to move downwards. Now, the one that you got to watch for is the p-value, because it's kind of like reverse psychology. Is opposite of what you see in the equation. That's what's really happening to it. So that's the one you got to be careful with. Also, what you should have found is that when A is greater than 1, you should find that the graph becomes more narrow. If A is between 0 and 1, then you should find that it gets wider. And finally, if A is less than 0, you should find that the graph is downward facing. Okay, so it's going to be like a frown. So that's kind of what I wanted you to get from that Desmos assignment. Now we're going to check what your skills are right now. So what you can do is, what I want you to do is figure out what these features are, and from there I want you to then plot those points and give me kind of a sketch of what this could look like. And then what you can do is check with your graphing calculator. Okay, so the first thing you're going to do is you're going to write the coordinates of the vertex. So what's important to note is that in the first case here, where we have negative 0.5, we have x minus. There should always be a minus in that equation. Now, in order to create that positive 3, that means that your p-value actually had to be negative 3, because two negatives together becomes a positive. So that's the only reason that you see a positive sign, is because your p-value is actually negative 3 in this case. This is your a value, and then your q value is plus 2. So what we want to remember is the vertex is actually the coordinates of P and Q. So if we know how many spots is going to the right or left, up, down, that's going to tell us what the vertex is doing. So in this case, in our first case, our vertex is going 3 units to the left, so that means -3, and it's going 2 units up, so our Q value is +2. So then I would plot that point as I did right there. And then this graph, if you look at it, this negative sign means that it's a frown. It's downward facing. So if it's downward facing, I'm going to write that over here since I'm on it. It's downward facing. We know that it's going to have a maximum value. Now the maximum value is always going to match the y coordinate of your vertex right here. So y will equal 2, and that is the maximum of your graph, the maximum height of your graph. The axis of symmetry is always going to match your p value. So remember, this is going to be your q value for the max or min value. Your equation of your axis of symmetry should always match your p value. So in our case, it's going to be always x equals, and then our p value is -3. So that's the line that cuts it straight down the middle. We already know it's downward facing, and we're also going to say that there is a vertical stretch or compression, so that's our A value. Since our A value is 0.5, we don't look at the negative. That only tells us if it's positive, if it's upward or downward facing. The 0.5 tells us that it's going to be wider. It's going to get wider than if we were to compare it to y equals x squared. The domain for the parabolas, if it's not a real life scenario, meaning there's no like time or x is not representing time or something that's logical in our reality, then we can say XER. So this is how we properly write it. So this is called set builder notation. So we say x such that x is an element of real numbers. That means x can be anything. Y such that our range is going to use that maximum or minimum value depending on which one we have. Since we have a max value, we're going to say that the graph exists where y is less than or equal to 2. So that's our answer from our max value. And then we would say YER. Our y-intercept is where the graph is going through the y-axis. So we can actually do that by hand algebraically. So that's where we set x equal to 0. So we would go y equals -0.5, and instead of x, we're going to go 0 plus 3 squared plus 2. So we're going to put that into your calculator or calculate that. We know that this is going to be 3 squared, and then we're going to multiply that by -0.5, and we're going to add 2 to that value. So that's going to be 9 multiplied by -1/2. So that's going to be -4.5. And then we're going to add 2 to that. So that's going to give me -2.5. Okay. So that's going to be important because we're going to then plot that right there. So -2.5 would be approximately there. So you're going to plot that on your grid, and that's going to give us a good kind of image of what we should be expecting here. We know that the graph is going to be symmetrical. So the graph is always symmetrical. So if you are 3 spots away for the y-axis, on the other side of that axis of symmetry, you're also going to be approximately 3 spots away. So I'm just going to line it up and go 1, 2, 3 spots away and plot a point right there. And then I'm going to draw a downward facing kind of U/V shape. And that's what my quadratic looks like. Our next one here is the coordinates of the vertex in this case are 1 and -4. Okay, so we always look at the value after the negative. That's our p value. And then this, including the sign, is our q value. So p and q are always our vertex. Now in this case, since our a value is positive, that means it's going to be an upward facing parabola. With an upward facing parabola, it's going to have a minimum value. And we know it's going to match the q value, which is y equals -4. So that should always match that. The axis of symmetry comes from your p, and that's going to be x equals 1. That's the equation that cuts it straight down the middle. Now, since we have a equaling 2, we know it's going to be more narrow. So we're going to say it's going to be more narrow. The domain, just like the previous example, would be x such that x is an element of real numbers, and our range y such that y is going to be greater than and equal to our minimum value of -4, and then we would say y-er. Our y-intercept, we can algebraically do this. So we would go y equals 2, 0 minus 1 squared minus 4. And then we could put that in, 2, and then in brackets we have -1 squared minus 4. What we want to remember is that whenever you square a negative, it becomes positive. So it's going to be -1 squared is +1, and we're going to still have to multiply by 2 and then subtract 4. You need to follow BEDMAS. So it'll be 2 minus 4, which is equal to -2. So that's our y-intercept. So I'll plot that on my grid, so that's there. And remember, it's symmetrical, so if that is one distance away from that axis of symmetry, on the other side it's also going to be one spot away. And then what I'm going to do is connect all those 3 points into kind of like a U/V shape. So it should not be a V, it should not be a U, it's kind of in between. Okay, and that's what you want to do to graph that image. Okay, so to check your understanding, I'm going to get you guys to pause this video and check off which one matches each response. So it's kind of like multiple choice, right? So I want you to pause it, this video, try this yourself. Okay, so I'm going to give you the answers. So you should have tried this all by yourself and then filled in the check mark which ones match, right? So I'm going to give you the answers. So for the first one, we want to graph y equals 0.5 x squared, and we want to compare it to the parent graph and say what is happening. Well, remember when a is between 0 and 1, that's going to make it wider. So in this case, it's going to become wider. Now, if you have 2x squared, that's going to become more narrow. So when the number is greater than 1 for a, it's going to become more narrow. So that's what we want to state here. Whenever it's between 0 and 1, we want to say wider. When it's greater than 1, we want to say more narrow. For the graph of y equals ax squared, what this means here is, what if the value is positive? Which way is it facing? Well, if it's a positive symbol or you don't see the symbol, that means it's upward facing. If it's less than 0, meaning that means that the graph is negative, you see an a value that is negative, that's going to be a downward facing graph. So that's going to be downwards, this one's going to be upwards. So let's look at the p value here. Remember, the negative should always be there. So you're looking at the value right after the negative, and that means that this is going 2 units either to the left or right. Okay, so whenever you're looking at the x minus p value, that's always only left and right directions. In this case, when it's going to the right, it's going to have a negative sign in the equation, so we're going to say 2 units to the right. This one actually means x minus -5. We need to see this negative, so that actually means our p value is negative, which means it's going to the left. So when your p is actually negative, going to the left. When your p is actually positive, it's going to the right. Now, outside of the brackets, whenever you have x squared, that value that's added and subtracted outside of it is going to be your up-down motion. So for the next example right here, we can see that it's going 4 units upwards. So you should have check mark that one. And x squared minus 3, you should be going 3 units down. Okay, so that is a summary of what I wanted you guys to take from that Desmos assignment. Hope you guys have a good day. See you guys tomorrow.